Picture this. You're an archaeologist in 1936, carefully brushing dust from what appears to be an ordinary clay pot in the ruins near Baghdad. But as you examine it closer, your hands begin to tremble. Inside this 2,000-year-old vessel, you discover something that shouldn't exist: a copper cylinder, an iron rod. Components arranged in a way that looks disturbingly familiar to anyone who's ever cracked open a modern battery. This is the story of the Baghdad battery, and it's about to shatter everything you thought you knew about ancient technology. Because if what some scientists believe is true, then our ancestors were creating electricity over 1,800 years before Alessandro Volta supposedly invented the first battery. And that's just the beginning of this mystery. Welcome back to the channel where we dive deep into history's most perplexing enigmas. I'm your host, and today we're venturing into a discovery so controversial that it's divided the scientific community for nearly a century. Some call it proof of advanced ancient civilizations. Others dismiss it as wishful thinking. But here's what nobody can argue with. These artifacts exist. They can generate electricity, and their true purpose remains one of archaeology's greatest unsolved mysteries. Now, before we go any further, I need to tell you something that's going to make this story even more intriguing. The original Baghdad battery? It's gone, vanished. Stolen during the chaos of the 2003 invasion of Iraq, along with thousands of other priceless artifacts. So everything we're about to explore is based on photographs, replicas, and the scattered notes of researchers who studied it decades ago, which means the truth might be lost forever. But that's not going to stop us from uncovering what we can, because this isn't just about one mysterious jar. It's about challenging our fundamental assumptions about human progress, ancient knowledge, and the possibility that our ancestors were far more sophisticated than we ever imagined. The year was 1936. The place was Khujut, Rabu, a small village southeast of Baghdad, near the ancient ruins of Ctesiphon. This wasn't some random archaeological dig site. This was the former capital of two mighty empires, the Parthian and the Sasanian, civilizations that controlled vast territories and trade routes for nearly 800 years. Wilhelm König, a German archaeologist working as an assistant at the Iraq Museum, was cataloguing artifacts when he made a discovery that would haunt him for the rest of his life. Among the pottery shards and ancient coins, he found something extraordinary: a yellowish clay jar, about 5.5 inches tall, containing a copper cylinder and an iron rod, all sealed together with bitumen, a natural tar-like substance. Now, König wasn't just any archaeologist. He had spent years studying ancient metalwork, and he had noticed something peculiar about certain silver artifacts from the region. They appeared to be plated with incredibly thin layers of gold, so thin and uniform that they seemed almost impossible to achieve with the primitive techniques historians believed were available at the time. As König examined this strange jar more closely, a wild theory began forming in his mind. The copper cylinder and iron rod weren't randomly placed. They were positioned exactly like electrodes in a galvanic cell. The bitumen seal would prevent the contents from leaking. And if you filled that jar with an acidic solution, grape juice, vinegar, even lemon juice, you would have all the components necessary to generate electricity. In 1938, König published a paper that sent shockwaves through the archaeological community. He proposed that this 2,000-year-old artifact wasn't just a storage container. It was a battery. And not only that, but it might have been used for electroplating, a process that wouldn't be rediscovered by modern science until the 19th century. The implications were staggering. If König was right, then ancient Mesopotamians had mastered electrical technology when the rest of the world was still fumbling around with bronze tools and stone sculptures. They had harnessed the power of electricity for practical applications over a millennium before Benjamin Franklin flew his famous kite. But here's where the story gets even more fascinating. König's discovery wasn't an isolated case. Similar jars were found at other sites in the region: Seleucia, on the Tigris, Ctesiphon itself, each one with the same basic configuration: clay vessel, copper cylinder, iron rod, bitumen seal. It was as if someone had been mass-producing these devices across the ancient Mesopotamian world. The scientific community's reaction was swift and brutal. How dare this German archaeologist suggest that primitive ancient peoples could have developed technology that took modern civilization thousands of years to achieve? The very idea went against everything they believed about human progress and technological development. Critics immediately began attacking König's theory. They pointed out that there was no other evidence of electrical technology in the ancient world. No wires, no other electrical devices, no written records describing the use of electricity. How could an entire civilization develop battery technology and then completely forget about it? But König had an answer for that too. He believed these batteries weren't used for powering lights or motors. They were used for something much more subtle and sophisticated: electroplating. The process of using electricity to deposit thin layers of one metal onto another. And when he looked at those impossibly perfect golden objects from ancient Iraq, he became convinced he was seeing the results of ancient electroplating. For decades, the Baghdad battery remained a curiosity, filed away in museums and largely forgotten by mainstream archaeology. But the story was far from over, because in the modern era, something remarkable happened. Scientists decided to test whether these ancient artifacts could actually work. The first major test came from an unlikely source: an electrical engineer at General Electric named Willard Gray. In 1940, inspired by a sensational magazine article about the Baghdad battery, Gray decided to build his own replica. He carefully recreated the jar using traditional materials and techniques, then filled it with copper sulfate solution. The results? It worked. The replica generated electricity. Not much, just enough to power a small light bulb for a few minutes, but it was undeniably electrical current. Gray's experiment proved that the basic concept was sound. These ancient artifacts could indeed function as primitive batteries. But Gray's test was just the beginning. Over the decades, more scientists would conduct more sophisticated experiments. They would test different electrolytes. They would connect multiple jars in series to increase voltage. They would explore potential applications from electroplating to electrotherapy. And every single test reached the same conclusion: the Baghdad battery worked. Whatever its original purpose, it was definitely capable of generating electricity, which meant that either ancient Mesopotamians had stumbled upon electrical technology by accident, or they had deliberately engineered these devices for electrical applications. The most famous modern test came in 2005, when the MythBusters team decided to tackle the Baghdad battery mystery. They built 10 replica jars using materials and techniques that would have been available to ancient craftsmen. They filled them with lemon juice, connected them in series, and measured the results. The outcome was dramatic. The 10 connected jars produced over 4 volts of electricity, enough to power small devices, create visible sparks, and yes, even perform basic electroplating. They successfully used their replica ancient batteries to plate a small copper token with zinc, proving that König's original electroplating theory was at least technically feasible. But the MythBusters experiment also revealed something troubling. While the jars could generate electricity, they weren't very practical as batteries. The voltage was low, the current was weak, and the whole system was incredibly inefficient compared to what you'd need for serious metalworking applications. This led to a new wave of theories about what the Baghdad battery might actually have been used for. Some researchers proposed medical applications, using mild electrical current for pain relief or primitive electrotherapy. Others suggested religious or mystical uses. Imagine the awe-inspiring effect of a statue that could deliver mysterious shocks to the faithful. The most intriguing theory came from Dr. Paul Craddock of the British Museum, who suggested the jars might have been used as props in religious ceremonies. Picture this. You're in an ancient temple, and the priest asks you questions about your faith. If you answer correctly, you can safely touch the sacred statue. But if you lie or give wrong answers, the statue delivers a mysterious shock, accompanied by a blue flash of light. The priest, controlling hidden batteries, could create the illusion of divine judgment. But for every theory supporting the battery hypothesis, critics had counter-arguments. They pointed out that conventional fire-gilding techniques using mercury were well known in the ancient world. They noted that no electroplating workshops or related equipment had ever been found. They argued that the jars were probably just storage containers for sacred scrolls, with the metal components serving as simple holders. The debate raged on, with neither side able to deliver a knockout blow. And then, in 2003, the mystery took a tragic turn that would change everything. When American forces rolled into Baghdad in April 2003, the world watched as Saddam Hussein's regime crumbled. But in the chaos that followed, something devastating happened that most people never heard about. The Iraqi National Museum, home to some of humanity's most precious archaeological treasures, was left completely unguarded. What happened next was nothing short of cultural catastrophe. Looters poured into the museum like vultures, smashing display cases, ransacking storage rooms, and stealing everything they could carry. In just a few days, somewhere between 14,000 and 15,000 artifacts vanished, nearly half of the museum's entire collection. Among them was the original Baghdad battery, the very artifact that had sparked decades of scientific debate. Think about that for a moment. The one piece of physical evidence that could have finally settled this mystery, gone, vanished into the black market, probably sitting in some private collector's vault, or worse, destroyed by people who had no idea what they were handling. It's like losing the Rosetta Stone, or watching someone use the Mona Lisa as kindling. The theft of the Baghdad battery represents more than just the loss of an artifact. It's the erasure of a crucial piece of evidence in one of archaeology's most hotly debated mysteries. Modern scientific techniques that didn't exist in König's time, advanced chemical analysis, electron microscopy, isotopic dating, could have finally revealed what substances the jar originally contained, how it was manufactured, and what it was actually used for. But here's what makes this loss even more heartbreaking. In the years following the invasion, international efforts managed to recover about 7,000 of the stolen artifacts. Museums, collectors, and governments around the world worked together to track down and repatriate these stolen treasures. But the Baghdad battery wasn't among them. It remains missing to this day, probably forever lost to science. So where does that leave us? We're left with photographs, research notes, and the testimony of scientists who studied the original artifact decades ago. We have the MythBusters experiments and dozens of other tests conducted on replica jars, but we no longer have the primary source material that could have definitively answered whether this was ancient technology or simply an unusual storage container. This loss has had an unexpected effect on the Baghdad battery debate. Without the original artifact to study, both sides of the argument have become more entrenched in their positions. Believers point to the electrical experiments and argue that the jar's theft proves it was too dangerous to mainstream archaeological narratives. Skeptics dismiss the whole thing as overhyped pseudoscience, claiming the loss conveniently eliminates inconvenient evidence against the battery theory. But let's step back from the politics and consider what we actually know. We know these jars exist. Multiple examples have been found across ancient Mesopotamia. We know they can generate electricity when filled with acidic solutions. We know the ancient world was far more technologically sophisticated than many people realize. And we know that conventional explanations for these artifacts have significant holes. The scroll storage theory, favored by many archaeologists, suggests these jars were designed to hold sacred parchments. The copper and iron components would have helped preserve the scrolls and keep them in place. The acidic residue found in some jars could be explained by the decomposition of ancient parchment and ink over thousands of years. It's a neat, tidy explanation that fits within our understanding of ancient technology and doesn't require any revolutionary rethinking of human progress. But it doesn't explain everything. Why this specific combination of metals? Why the precise electrode-like positioning? Why the careful sealing with bitumen that would be perfect for containing liquid electrolytes? The medical theory offers another intriguing possibility. Ancient civilizations were well aware of the therapeutic effects of electric fish. The Greeks and Romans used electric rays for treating headaches and other ailments. But electric fish weren't found in Mesopotamian rivers. Could ancient engineers have developed artificial alternatives? Dr. Paul Kaiser of the University of Alberta has argued that the Baghdad battery could have been used for primitive electrotherapy, mild electrical stimulation for pain relief, perhaps even early forms of electroacupuncture. The voltage produced by these devices would have been perfect for such applications, strong enough to create a noticeable sensation, but not dangerous enough to cause serious harm. This theory has some compelling evidence. Copper and iron were both associated with healing in ancient Mesopotamian culture. Temple medicine was highly advanced, and priests often doubled as physicians. Using mysterious electrical devices to treat patients would have enhanced both the healing process and the priest's reputation for possessing supernatural powers. Then there's the religious deception theory proposed by Dr. Craddock. Ancient temples were notorious for using clever technology to create miraculous effects. Hidden mechanisms made statues move. Secret pipes carried the voices of priests to create divine pronouncements, and elaborate hydraulic systems powered fountains that seemed to flow by divine intervention. Adding electrical shocks to this repertoire would have been incredibly effective. Imagine a devotee approaching a sacred statue, believing they're about to receive a blessing. If they've been faithful and generous, they experience nothing unusual. But if they've been dishonest or stingy with their offerings, the statue delivers a mysterious shock that seems to come from the gods themselves. The electrical current produced by Baghdad batteries would have been perfect for this kind of religious theatre. Strong enough to create a memorable shock, but not powerful enough to cause serious injury. And the blue sparks that can be generated by these devices would have seemed utterly supernatural to ancient peoples. But here's what's really fascinating about this debate. Every theory requires us to acknowledge that ancient Mesopotamians were far more sophisticated than traditional archaeology suggests. Whether they were developing early medical devices, creating elaborate religious effects, or actually experimenting with electricity, they were demonstrating advanced scientific thinking. Consider the precision required to construct these devices. The copper had to be shaped into perfect cylinders. The iron rods had to be positioned exactly in the center. The bitumen sealing had to be applied in just the right way to prevent leakage while allowing access to the interior. This wasn't random craftsmanship, it was careful engineering. And remember, we're talking about a civilization that had already given the world cuneiform writing, sophisticated astronomy, advanced mathematics, and complex irrigation systems. The Babylonians were tracking planetary movements with incredible accuracy. They understood mathematical concepts that wouldn't be rediscovered in Europe for centuries. Is it really so impossible that they might have stumbled upon electrical phenomena? The timing is significant too. The Parthian and Sasanian periods, when these batteries were created, were eras of incredible cultural exchange. Trade routes connected Mesopotamia with China, India, the Mediterranean, and beyond. Knowledge flowed along these routes just as freely as goods. If electrical technology had been developed anywhere in the ancient world, this would have been the perfect place and time for it to appear. Modern chemistry tells us that the components of the Baghdad battery are ideally suited for generating electricity. Copper and iron create an excellent galvanic couple when immersed in acidic solutions. The voltages produced are consistent and predictable. Even the bitumen sealing makes sense from an electrical engineering perspective. It would prevent contamination and maintain optimal conditions for electrochemical reactions. So why does mainstream archaeology remain so resistant to the battery theory? Part of it is simple scientific conservatism. Extraordinary claims require extraordinary evidence, and extraordinary evidence is exactly what we lost when the original artifact was stolen. But there's also something deeper at work, a reluctance to fundamentally revise our understanding of human technological development. The linear model of progress, primitive beginnings leading inevitably to modern sophistication, is deeply embedded in how we think about history. The idea that ancient peoples might have achieved technological breakthroughs that were then lost or forgotten challenges this comfortable narrative. It suggests that human progress isn't always forward, that knowledge can disappear as well as accumulate. This resistance isn't entirely unreasonable. History is littered with fantastic claims about ancient supercivilizations that turned out to be complete nonsense. The pyramids weren't built by aliens. Atlantis wasn't a real place. And most supposedly impossible ancient technologies can be explained through conventional archaeological methods once you dig deeper into the evidence. But the Baghdad battery is different. It's not based on wild speculation or misinterpretation of evidence. It's based on physical artifacts that multiple scientists have tested and confirmed can generate electricity. The question isn't whether these devices work, it's what they were originally designed to do. And that's where things get really interesting. Because recent discoveries have started to paint a picture of ancient Mesopotamian technology that's far more advanced than anyone previously imagined. Archaeological excavations have uncovered sophisticated chemical laboratories, precision-crafted glass lenses, and metallurgical techniques that rival modern methods. Take the Nimrud lens, discovered in the ruins of ancient Assyria. This rock crystal lens, over 2,700 years old, is so precisely crafted that it could have been used for magnification or even starting fires by concentrating sunlight. Or consider the ancient steelmaking techniques found at sites across the region, producing metals with carbon content and tempering methods that weren't supposed to exist for another 1,000 years. These discoveries suggest that ancient Mesopotamian craftsmen weren't just skilled artisans, they were experimental scientists. They tested materials, refined techniques, and pushed the boundaries of what was possible with available technology. In this context, the development of primitive electrical devices doesn't seem quite so far-fetched. But let's dig deeper into the technical aspects of how these batteries actually work, because the science behind them reveals something remarkable about ancient understanding of chemistry and metallurgy. When you place copper and iron in an acidic solution, you create what's called a galvanic cell. The iron acts as an anode, slowly dissolving and releasing electrons. The copper acts as a cathode, accepting those electrons. The acidic solution serves as an electrolyte, allowing ions to flow between the two metals. This electrochemical process generates a steady electrical current that can continue for hours or even days, depending on the strength of the acid and the size of the metal components. The voltage produced is relatively low, usually between 0.5 and 1.1 volts per cell, but it's remarkably consistent and predictable. Now, here's what makes this so fascinating from an archaeological perspective. Creating an effective galvanic cell requires precise understanding of several scientific principles. You need to know which metals work best together. You need to understand how different acids affect the reaction. You need to grasp the relationship between surface area and electrical output. And you need to solve practical engineering problems like preventing corrosion and maintaining proper electrolyte levels. The Baghdad battery demonstrates mastery of all these concepts. The copper cylinders are perfectly sized to maximize surface area while fitting inside the clay jars. The iron rods are positioned to optimize the electrochemical reaction. The bitumen sealing system would have allowed ancient engineers to control electrolyte levels and prevent contamination. This isn't accidental design, it's sophisticated engineering. But perhaps the most compelling evidence for intentional electrical use comes from the distribution patterns of these artifacts. They're not randomly scattered across archaeological sites like you'd expect from storage containers. Instead, they cluster around specific types of buildings, temples, workshops, and elite residential areas, places where specialized knowledge would have been concentrated and applied. Even more intriguing is the consistency of their construction. Despite being found across different cities and spanning several centuries, Baghdad batteries show remarkably uniform design features. The ratios between copper, iron, and ceramic components are nearly identical. The manufacturing techniques are standardized. This suggests not just isolated experiments, but an established tradition of battery production passed down through generations of craftsmen. The chemical analysis of residues found inside these jars tells another fascinating story. While some contain the acidic compounds you'd expect from decomposed parchment, others show traces of substances that make no sense for scroll storage, copper salts that form during electrochemical reactions, iron oxides consistent with galvanic corrosion, chemical signatures that point toward electrical rather than storage applications. Modern scientists have also discovered something else remarkable about these ancient batteries. When connected in series, they produce voltages that align perfectly with the thresholds for various electrical phenomena. 2 or 3 jars generate enough current for basic electroplating. 5 to 7 produce the voltage needed for noticeable electrical stimulation. 10 or more create enough power for visible sparking and more dramatic electrical effects. It's as if ancient engineers had systematically tested different configurations to achieve specific electrical outputs. They weren't just stumbling around in the dark. They were conducting organized research into electrical phenomena, documenting their results, and scaling their systems to match intended applications. This level of systematic experimentation suggests something profound about ancient Mesopotamian science. We're not looking at a civilization that accidentally discovered electricity and then forgot about it. We're looking at a culture that actively investigated electrical phenomena, developed practical applications, and maintained this knowledge for centuries. But if ancient Mesopotamians really did master electrical technology, what happened to it? Why don't we see electrical devices spreading to other civilizations? Why isn't there more evidence of electrical applications in the archaeological record? The answer might lie in the highly specialized nature of this knowledge. Unlike pottery or metalworking, which could be learned through observation and practice, electrical technology would have required deep understanding of invisible forces and complex chemical reactions. This kind of knowledge would have been closely guarded by priests and craftsmen, passed down only to trusted disciples within specific institutions. When those institutions collapsed, through war, political upheaval, or economic disruption, the knowledge would have died with them. Unlike stone buildings or metal artifacts, electrical expertise couldn't survive the fall of the civilization that created it. It was too fragile, too dependent on living traditions of teaching and practice. We see similar patterns throughout history. The Romans developed concrete that was superior to modern formulations, but the knowledge was lost during the empire's collapse. Medieval European craftsmen created stained glass with colors that modern chemists still can't replicate perfectly. Traditional Japanese swordsmiths produced steel with properties that industrial metallurgy struggles to match. Knowledge, especially highly technical knowledge, is more fragile than we like to admit. It can disappear faster than the artifacts it creates, leaving behind only mysterious remnants that later civilizations struggle to understand. This fragility might explain why electrical technology vanished from the ancient world while leaving behind just enough evidence to tantalize modern researchers. The Baghdad batteries survived because they were made of durable materials and preserved in favorable conditions. But the knowledge of how to use them, why to use them, and what they were capable of achieving died with the last practitioners who understood their secrets. And that brings us to one of the most haunting aspects of this mystery. We're not just looking at ancient artifacts, we're staring into a void where human knowledge once existed but has been irretrievably lost. Every time we speculate about the Baghdad battery's purpose, we're trying to reconstruct not just an object, but an entire scientific tradition that vanished from history. The theft of the original artifact makes this loss even more poignant. Modern analytical techniques could have revealed chemical fingerprints, manufacturing methods, and usage patterns that might have finally solved this mystery. Advanced spectroscopy could have identified trace elements that would point towards specific applications. Microscopic analysis could have revealed wear patterns that would indicate how these devices were actually used. Instead, we're left with photographs, replicas, and the testimony of researchers who studied the original decades ago. It's like trying to understand a symphony when you can only hear echoes of individual notes, or attempting to reconstruct a painting from faded sketches and second-hand descriptions. But maybe that's fitting, because the Baghdad battery has always been about more than just ancient technology. It's about the limits of human knowledge, the fragility of civilization, and the humbling realization that our ancestors might have achieved things we're only beginning to understand. Whether these artifacts were batteries, storage containers, or something else entirely, they represent a moment when human ingenuity pushed against the boundaries of what seemed possible. They remind us that progress isn't always linear, that knowledge can be lost as well as gained, and that the past might hold surprises that challenge our most basic assumptions about the march of civilization. In our modern world, where we carry more computing power in our pockets than existed in the entire world just decades ago, it's easy to assume that technological sophistication is a recent achievement. The Baghdad battery suggests otherwise. It whispers of ancient experiments conducted in forgotten laboratories, of craftsmen who understood forces they couldn't fully explain, of knowledge traditions that flickered briefly in the darkness of history before vanishing forever. And perhaps that's the real lesson of the Baghdad battery. Not whether ancient Mesopotamians had electricity, but what it means when entire bodies of human knowledge disappear without a trace. In an age when we're creating more information than ever before, when digital archives seem permanent and indestructible, the Baghdad battery serves as a stark reminder that even the most sophisticated knowledge can slip through our fingers like sand. The mystery continues to evolve, drawing new researchers into its orbit and inspiring fresh experiments. Scientists around the world continue building replicas, testing new theories, and pushing the boundaries of what these ancient artifacts might have accomplished. Each experiment adds another piece to the puzzle, even as the complete picture remains tantalizingly out of reach. But that's what makes this mystery so compelling. It's not just about solving a historical riddle, it's about confronting the possibility that human achievement has always been more complex, more surprising, and more fragile than we dare to imagine. The Baghdad battery forces us to question not just what ancient peoples knew, but what we think we know about the nature of knowledge itself. So here we stand, almost a century after Wilhelm König first picked up that mysterious jar, and the questions have only multiplied. Every scientific test confirms that these devices can generate electricity. Every historical analysis reveals a civilization far more sophisticated than we previously understood. Every chemical examination uncovers evidence that points in conflicting directions. And yet, the silence from mainstream archaeology grows louder with each passing year. What's particularly striking is how modern discoveries keep shifting the ground beneath this debate. In recent decades, archaeologists have uncovered evidence of ancient Mesopotamian achievements that would have seemed impossible just generations ago. Precision optics that rival modern lenses, chemical processes that we're still trying to reverse engineer, metallurgical techniques that produce materials with properties we can barely explain. Each new discovery makes the Baghdad battery seem less like an anomaly and more like part of a pattern a pattern of ancient innovation that doesn't fit neatly into our textbook timelines of human progress. Consider what we now know about ancient Mesopotamian medicine. Temple records describe surgical procedures of remarkable sophistication. They document the use of precise pharmaceutical compounds derived from complex chemical processes. They detail therapeutic techniques that wouldn't seem out of place in a modern medical textbook. If these ancient physicians were experimenting with complex chemistry and advanced surgical techniques, is it really so far-fetched that they might have investigated the therapeutic applications of mild electrical stimulation, especially when we know they were already familiar with the medical properties of electric fish from other regions? The religious applications become even more intriguing when you consider the elaborate technological systems that archaeologists have uncovered in ancient temples. Hidden chambers with acoustic properties designed to amplify whispers into godlike voices, mechanical systems that made statues appear to move on their own, hydraulic networks that created mysterious fountains and flowing effects. These weren't primitive people stumbling around with crude tools. These were sophisticated engineers who understood how to manipulate physical forces to create desired psychological effects. Adding controlled electrical shocks to their repertoire would have been a natural extension of existing capabilities. But here's what really haunts me about this mystery. We're not just dealing with missing evidence, we're confronting the possibility that entire categories of ancient knowledge have vanished so completely that we can't even imagine what we've lost. Think about it this way. If our civilization collapsed tomorrow and future archaeologists found smartphones in the ruins, would they be able to deduce the existence of the internet? Would they understand that these devices were connected to a vast global network of information? Or would they assume they were just elaborate calculators or storage containers? The Baghdad battery stands as a testament to one of archaeology's most enduring mysteries, a puzzle that challenges everything we think we know about ancient knowledge and human progress. Whether these artifacts were primitive electrical devices, elaborate religious props, medical instruments, or simple storage containers, they force us to confront an uncomfortable truth. Our ancestors may have been far more sophisticated than we ever dared imagine. In a world where we've lost the original evidence to theft and chaos, where scientific tests confirm electrical capability but archaeological context remains disputed, perhaps the real mystery isn't what these jars were used for. Perhaps it's what their very existence tells us about the fragility of human knowledge and the humbling possibility that entire chapters of our technological heritage have already slipped through the cracks of time. The next time you hold a modern battery in your hands, remember that clay jar from ancient Mesopotamia. Remember Wilhelm König's trembling discovery. And ask yourself, what other secrets are buried beneath the sands, waiting to rewrite the story of human civilization? What do you think? Could our ancestors have mastered electricity 2,000 years before we thought possible? Let me know in the comments below, and if this mystery fascinated you as much as it did me, subscribe for more deep dives into history's greatest enigmas.